All right, here we go with our next video. This is applications. Ferris Wheeler's Day Off is what this is called. We are on page 207 of your workbook. So application questions with sinusoidal. So whether it's a sine graph or a cosine graph, which we saw in the last section, they're called sinusoidal, whether it's sine or cos, and that ends up being a bit of a sometimes confusing for students because you will be asked on your diploma exam, draw this as a sinusoidal, which could be either sine or cosine. Tangent is different, and we'll get to that in the next section, but this could be either sine or cos. And the types of problems that we would use in this section, or that you would typically see in an applications question, are going to be things with repeating patterns. So things that have repeating patterns that happen over and over again. This question has to do with a Ferris wheel, and you're measuring the height of somebody on a Ferris wheel. You're going to go up, and then you're going to come down, and then you're going to go back up, and then you're going to come back down. And it ends up being what's called a periodic function, because it's going to have a period of however long it takes you to get around the Ferris wheel. And that's one of the obvious examples of an application that could use this. Other things, sometimes you see questions that use looking at the days of the year, and you're looking at sunrise times, or you're looking at temperatures. Temperatures throughout the year, they go up and then they come back down, and they go up and they come back down. Or a time of sunrise, the sunrise gets later and later in the year, in the winter, and then earlier and earlier during the summer. And it has a period of 365 days because this cycle repeats every 365 days. All right, so let's start off with this one. Ferris wheel that has a radius of 5. The lowest point of the Ferris wheel is 0.5 meters above the ground. Sam gets onto the bottom of the Ferris wheel. It takes him 8 seconds to travel from the bottom up to his highest height. We will be examining the relationship between his height above the ground and the time he's on this Ferris wheel. Yes, it's going around in a circle, but we are measuring, this is time in seconds that we are measuring on the x-axis. So this will end up being a function that's not going to be circular. He's going to go up and then he's going to come down, but time is always moving along as we go to the right on this graph. Make sure, for real world problems, we're going to make sure that your calculator is in radian mode. Okay, so whenever we do something that is an application, make sure that we are in radian mode unless there's a specific reference to degrees. And let's go ahead with this. Okay, so at 0 seconds, at 4 seconds, at 8 seconds, we are needing to figure out his height above the ground. It tells us that he has a lowest point of 0.5. So at time is 0, that's his height. He gets on the bottom. It takes him 8 seconds to travel from the bottom to the top. So at 8 seconds, he's going to be at his highest height. Now, where is that? He's on a Ferris wheel that has a radius of 5 meters. And if his Ferris wheel has a radius of 5 meters, there's little cars going around. If this has a radius of 5 meters, that's this, right? But it's also this or this. And if this is a 5-meter radius, then that means its diameter is 10. And if his lowest height is 0.5, his highest height will be 10.5. At 4 seconds, if he's going around the circle, at 4 seconds, he's halfway up. He's at his median height. He's at halfway up that he's going to be. And so that median height is going to be halfway between 0.5 and 10.5. But it's going to be 5.5 meters. Halfway between 10.5 and 0.5 is going to be 5.5. Now, you might recognize that already, that if we're going to start to graph this, that average height, that median height ends up being 5.5 meters. That's this. That's going to be the median on this graph. And at 0 seconds, if he's at 0.5 meters, and at 8 seconds, he's at 10.5 meters. That means halfway in between those, at 4 seconds, he's at 5.5. And you can probably already see where we're going with this. We're going to continue on with this table of values for every 4 seconds. And if we continue on with these heights, at 12 seconds, he's coming back down. And he's at 5.5 meters. At 16 seconds, he's made one full revolution at 16 seconds. Because it takes him 8 seconds to get from the lowest to the highest. It takes another 8 seconds to do that. So therefore, what can we say? We can say that period is equal to 16 seconds. If we continue on with this behavior, he goes back up 5.5, 10.5, 5.5, 0.5. And as we start to graph this out, every 4 seconds, he's either at a minimum, a median, or a maximum, or a median, or a minimum. And it's going to look like this. When we start to sketch this, nice smooth curve. And it comes in flat when we get to that maximum, right through that median point, and it looks like this. Beautiful. Determine the equation for a sinusoidal function that we just graphed. Express the equation in the form h of t is equal to a sine b of t minus c plus d. Okay, so we have our parameters a, b, c, and d. We have our variables of t and h of t. And we know what those all end up being now. It's asking us to graph it as a sine graph. It doesn't technically say whether a is positive or a is negative. Let's just assume that, well, let's just do this for a being a positive value, which means we have a positive sine graph, which means our start point on this curve, remember, is where the graph crossed the median line going uphill. So it's going to be our first median line going uphill. So it's that point there at 4, 5.5. So when we start to put this all together, h of t, it's no longer y, let's call it h of t. Our amplitude was the radius. It is 5 sine. Our b value, we should probably write all this out. Sorry about that. But let's write these down first. A is equal to 5. We do have units on this of meters. And that was the case because that was the radius. We have a d value, we said of 5.5, because that ends up being your median height. That's also in meters because it's a vertical measurement. So we can call this our median. We have b is equal to 2 pi divided by period. And we said it took 16 seconds to do one full revolution. So this is pi over 8. Now, C is going to depend on which we're doing, but we're doing this as a sine graph, and we said that C ends up being your start point for positive sine is here. So it's been shifted to the right by 4. So C is equal to 4. And our measurement on this is in seconds. Technically, B is not in seconds. What B is measuring, it's measuring cycles per second. But all that we really need to do here, if we wanted units on period would be in seconds. Now that we have this, we can put this all together. H of t. H of t is equal to, we have 5 as our amplitude, sine If b is pi over 8, remember that that's factored away from a to the minus 4. And then we have plus 5.5. Describe, if you're asked to describe in a written response on a diploma exam. Let's make sure that we connect all the dots here. A is equal to your radius of the Ferris wheel. Always relate it back to the context. This is in meters. D is your, it's not enough to just say that D is your median line because we need to relate it back to the context. So we can say that D is your median line, but we should also include that it is your average height. On your Ferris wheel. Your average height on your Ferris wheel. You could also say that it's your height of the center of the wheel, right? Because the middle, the center of the Ferris wheel would be 5.5 meters up. B is related to the period. It's not the period, but it's related to the period. It's equal to 2 pi over period when period is equal to 16 seconds. Take 16 seconds for one revolution. Make sure that you're tying all of this back into the context. C is a little, it's a little nebulous here. It's a little synthetic of what we're doing here. C is your time to reach your median height. It's the time at which Sam looks at the center and says, oh, I'm at the same height as that center. Whatever. All right, so when we put this into our calculator, number 5 says use your graphing calculator to determine the height of a rider at 9.3 seconds. When we put this into your calculator to graph, we want to make sure of a couple of things. Depending on what version of calculator you're using, you probably want to open up a bracket after sine. Pi over 8, and then we're going to open up another bracket. Theta, or x in this case, minus 4. Close the brackets twice, plus 5.5. So if we graph that into your calculator, now your window settings, let's come back to here. These should be your window settings. So let's start x minimum at 0 and x maximum at 34. Let's have y minimum at 0 and a y maximum at 13 when you go into your window settings. That way, what you see on your screen should look just like this. Now this question is asking for what's your height of the rider at 9.3 seconds. So what this is getting at is this is getting at, and this is 9.3. What is this going to be? So 9.3 comma, that's what we're trying to find. When you put this into your calculator, if you hit trace, or on a Casio, you would hit G-solve and then value. But if you hit the trace button and then type in x equals, then just type in 9.3 and it'll jump to that spot. That one's a little more straightforward to get if you have an x value find a y value. What we would write this as, h at 9.3 is equal to 9.9 meters. The question 6 is asking the question backwards. Question 6 says, use your graph and calculator to determine how long the rider is 9 meters or higher in one full revolution of the Ferris wheel. So when are you over 9 meters? So here's 9 meters here. One full revolution stops here. So within here, how long are you above 9 meters? We're going to need to find those 2 points. Those 2 points when he's actually at a height of 9 meters. We're going to do this on your calculator. On a Casio, it's not too bad. On a Casio, you just go into GSolve. We know the Y value. We are trying to find an X value, so this is your XCalc feature. And it should just jump to that point when you say Y is equal to 9. And it should just jump to that point. And then once you have that point, it should give you the point 10.03, comma 9. And then you arrow over to the other one, and maybe it gives you 5.97 first, and then you arrow over to the other one, whatever. It gives us those 2 points. Now, TI people, it's a little more involved than that. TI people, you're going to have to graph a second line. Y2 is equal to 9. And if Y2 is equal to 9, then it's going to graph for you. It will graph for you this, right? It'll graph that horizontal line at 9. And we need to find intersection. So go second trace. And I think number 5 is intersect. So second trace button has all of your calculating features for your graph. And then I think it's number 5 is intersect. And it asks, what's the first curve, what's the second curve, and where's your guess? The guess is integral to this in that first curve is Y1, second curve is Y2. The guess, you just move the bug closest, somewhere closer to that point. It's just your calculator asking for which intersection point you're trying to find, and you're going to have to go through that whole process twice. We go through that process twice, we find this. You should write those down. And now once we have that, your time above 9 meters will equal the difference of those two things. 10.03 minus 5.97. It's equal to 4.1 seconds above 9 meters. So make sure you can do that on your calculator. If we want to write the same equation in the form of cosine, a lot of it looks the same. This is still 5. Cosine is still pi over 8, or cosine of pi over 8. I'm going to leave that blank for now. This is still plus 5.5. Is going to be your D value, your median height. The only thing that's going to be different is going to be our start point for cos. And if it wants us to write it as cosine, now it doesn't say whether or not cosine is positive or negative, it just wants to write it as a cosine graph. And that ends up being nice in that for a cosine wave, sorry, I keep jumping up and down with rolling my page back and forth. But here there's this minimum that happens right on the y-axis. That means if we graph this as negative cosine, there is no phase shift, right? So if we go to graph this, our answer could just be this. So cosine of pi h theta. If we have this as negative cosine, negative 5 cos. If we graph it as -5 cosine, it could be this. We could also graph this or write an equation of +5 cosine, but in that case, we have a phase shift of theta minus, it was 8 seconds for him to get to the maximum height. So it's a shift of -8 to the right. And in here, oh gosh, sorry about that. This is, that ends up being my answer to 8. And if that's my answer to 8, so we kind of just mentioned this. Why would we want to do this? Well, because now we have no phase shift. What that means in terms of the equation is C is equal to 0. It just tidies up the equation, makes it cleaner. My bad for missing that. Either of these are fine if it doesn't tell you which one you're looking for. They do mean the same thing. All right. The following represents the height above ground of one of the cars on the Ferris wheel. So we have a different Ferris wheel here. It appears that we have a maximum height of 19. It appears that we have a minimum height of 1. Determine the height of the hub, or the center of the Ferris wheel. So the center of the Ferris wheel is going to be right in the middle of 19 and 1. How do we find that middle? It's going to be max plus min divided by 2. We're just going to find your average height. And if your average height is that, 19 plus 1 divided by 2, that is 10. It ends up being our median line. So 10 meters is the height of this Ferris wheel. Our radius. How much from the center do we go up? How much from the center do we go down? That ends up being our radius. And so if we have maximum minus your median, it's going to be 19 is your maximum height, 10 now is your median height. So this is 9 meters up and 9 meters down. So we have a 9-meter radius. State the period. How long does it take to do one cycle? This one appears to, it starts at a minimum. Our next minimum happens at 100 seconds. So therefore, period equals nice and straightforward, not a big deal. Write an equation in this form, both for sine and for cosine. I'd like you to take a second to do this. Press pause, write both of these equations. Let's just do each of these just with, well, let's just see what you give me, either way. So let's just do both these. Hit pause and go ahead and do these. All right, so what we should have here is h of t. We have an amplitude of 9 because that's the radius of this wheel. Sine, we have 2 pi over period. If our period is 100 seconds, and this ends up being pi over 50. Actually, let's leave it in this form of, it does ask for it in this form of 2 pi over p. Normally we would write it as pi over 50, but if it's asking for in 2 pi over p, especially in a numerical response, if it's asking us for us to include p in here, this would be 2 pi over 100. Normally we would simplify. For sine, what do we have for sine for C value? If we look at what's going on with our graph, for sine, our start point of this seems to happen right about here. Can we know, is it going to be, like, looks like maybe 25-ish? Can we know more than that if it's 25 or 26? We can, actually. The fact that this is 100 to do one full cycle means in 50 seconds, it gets to this maximum. And then halfway in between this maximum and minimum is here, which actually is 25 seconds. So we can know that that should be t minus 25. If we do this as cosine, 9 cosine in this form, it would be 2 pi over 100, or pi over 50 is good too. And then what happens with cosine? Let's have a look at our graph. Cosine, remember this start point of positive cosine happens at the maximum. So this is 50 to the right, makes this t minus 50 plus 10. Also acceptable, and actually it ends up being pretty solid, is if we call this negative cosine. It tidies this up. Now we don't have a c value. C is just 0 now. And so it would look like this, and either would be fine unless you're specifically asked for a reflected cosine or not. Number 13. In a small ocean port, water has a maximum depth of 18 meters at 7 o'clock p.m. and minimum depth of 8 meters 6 hours later. The scenario models a sinusoidal function where t is your time in hours after 7 p.m. That's kind of a critical part to this. So your clock starts, time 0 is at 7 p.m. We have a maximum depth of 18 meters at that time. And let's graph this. We have a maximum depth of 18. Our minimum depth is 8. And so if I'm graphing it like this, so here's, say there's 18. If I have a scale of every 10, then this ends up being 0,18. At time 0, you're at 18 meters. Your minimum depth is 8 meters 6 hours later. 3, 4, 5, 6. We have a nice scale on our consistent scale on our x-axis, or on our t-axis in this case. Let's call this t. Let's call this h of t. I'm labeling axes. I have a minimum of 8, which is just going to be below this tick mark of 10. That kind of infers, when do I have maximum depth again? Well, if I have a minimum at 0 or a maximum at 0 and minimum at 6 hours later, then 6 hours after that, we're back up to a maximum depth. And so it's going to look like this. And if we draw a graph of this, we're going to have a median line. Always have our median line. What will we have for D should equal max plus min over 2. 18 plus 8, our average height. 18 plus 8 is 26 over 2 is 13. So D equals 13. All right, so there's 0,18. Here's 6 hours, 8 meters deep. At 3 hours, you're at your average depth, which is 13 meters. Also at 9 hours, you're at 13 meters. And then at 12 hours, we're back up to 18 meters deep. We have an amplitude. max minus min over 2, which is going to be 18 minus 8 over 2, which is 10 over 2, which is just 5. Is our amplitude. That 10 measures the whole height of the wave, right? If I do just max minus minimum, if that whole thing is 10, then half of the wave, which is amplitude, is going to be 5. All right, so that all makes some sense. This now says determine your cosine equation. That's nice that we want a cosine equation because we do have a maximum at time 0. So we're not going to have a c value. So c is equal to 0. What do we have for our equation? H of t is equal to a is 5 cosine. We should calculate, what are we going to need in here? We're going to need b. And how do we find b? b is equal to 2 pi over period, which is 2 pi over how long does it take to do one full cycle? It is 12 hours. So b is equal to pi over 6. So 5 cosine pi over 6t. And then the last part is d is our median line of 13 meters. All right, for number C, determine the depth of water to the nearest tenth of a meter at 5 p.m. Okay, at 5 p.m., that means, where are we at? That means T is equal to, 5 p.m. is, if we're talking about the next evening is 5 p.m., it's 22 hours after 7 p.m. tonight. 7 p.m. tonight, if that's when we start our measurements at 7 p.m. tonight, then 5 p.m. tomorrow is going to be 22 hours. Or we could even use t is equal to negative 2 hours because it's 2 hours before 7 p.m. So either way, this should work. So this is looking for h of 22. And if h 22 is going to be equal to 5 times cosine pi 6 times 22, and then we'll add 13. When we push this into our calculator, make sure that your calculator is in radians. And so in radians, what do we have? We have 5 cosine is 11 pi over 3 plus 13. Make sure you use brackets around here when we have a cosine of 11 pi over 3. Close your bracket around that. Depending on which calculator you're using, it might make a difference in here. And we should get exactly 15.5. What are we measuring here? This is in meters. D, determine the first time after 9 a.m. that the depth of the water is 10 meters. So in this case, now we have h of t is equal to 10. So on a TI calculator, we will have pi over 6 times x plus 13, brackets around this. We're going to have y2, because we're trying to find the first time that the depth of water is 10 meters. First time after 9 a.m. that the depth of water is 10 meters. And so we are going to want to find that intersection point. So on a TI, you'll need to find intersection point. On a Casio, you can do G-solve We know a y value, so gsolve and then xcalc when y is 10. Either way, we get this as a point, 16.23. 16.23, comma 10 is our point here. And if we have 16.23, comma 10, we need to take that one step further to interpret what that means as a time. That means we have 16 hours after 7 p.m. plus 0.23 of an hour. And 0.23 of an hour, we're going to have to multiply that by 60 to determine how many minutes that is. Okay, so 16 hours after 7 p.m. 16 hours after 7 p.m. is 11 o'clock, right? So 5 hours after 7 p.m. is midnight, and then another 11 hours. So therefore, 11, and then we need to take that 0.23 portion and multiply it by 60 minutes to convert it into time. And 0.23 of an hour is just under a quarter of an hour, right? And so we end up with 11 hours and 14 minutes a.m. is when it has a depth of 10 meters. Number 14. Number of squirrels living in a particular area can be modeled by the function n of t is equal to a cos b t minus c plus d. T is your time in months since measurement begins. 5 months it reaches a population of first maximum of 200. At 12 months, it has your first minimum of 110. Determine the values of a, b, and d for the function above and relate them to the context of the question. So we're not looking for c, but we are looking for what a, b, and d end up being. All right. So we do have a maximum of 200 of a population and a minimum population. Those are heights of this wave if we were to graph this. And we know that d is just going to be the average of those heights. It's going to be your maximum plus your minimum divided by 2. So we end up with 310 divided by 2 is 155. Now, what does that mean? What is that measuring? Our units on that is squirrels. Therefore, your average number of squirrels, because we have to relate this to the context, the average number of squirrels is 155. Here's D. A. A is max minus min divided by 2. It's 200 minus 110 over 2. It's 45. How does that relate to the context? Well, this one's a little bit more artificial, this idea. But if your average number of squirrels is 155, it goes up 45 from that, and it goes down 45 from that. 45 squirrels is how many more or less population changes from average? How many more or how many fewer squirrels your population changes from average? How much it varies, essentially, is what's going on with that. And then our last one, B. B is equal to 2 pi over the period of this. we had at 5 months, we have a maximum, and at 12 months, we have a minimum. That means my next maximum would be another 7 months later, right? There's 7 months between this maximum to this minimum, and it's going to take another 7 months to get back to a maximum again if this is a periodic function. So therefore, period is 14 months. So 2 pi over 14. So b is equal to pi over 7. What this has to do with in the context, this is how many cycles per month, essentially, that we're getting at. So it's pi over 7 cycles per month. This has to do with the period. Our period of 14 months. Our period of 14 months is how long this cycle takes to repeat. How long it takes this cycle to repeat our squirrel population. It goes up, it goes down, it goes up, it goes down. And that's what's going on here. Yeah, that's it. That's it. That's the end of this section. Hope this was helpful. Thank you.